Hi students, and we're going to take a look at relations and functions here. I want to just go over some of the vocabulary, the key points that we introduced in the last video series. So this top line here, x variable, input variable, independent variable, horizontal axis variable, these are all synonyms. They all mean or refer to the same thing, and we can use them interchangeably. The same is true for this line here, y variable, output variable, dependent variable, vertical axis variable. These are all referring to the same thing, and we can use them interchangeably. So make sure that you understand the connection between these vocabulary words, because during these videos and during your homework and assignments, we're going to be using these terms interchangeably. We're going to be using some more than others, but you want to make sure that you're clear on the understanding and definitions of each. So let's take a look at today's topic. We're going to be taking a look at a continuous relation versus a discrete relation. We're going to be defining a continuous relation in grade 10 as a relation where the independent variable can take any real value within a given interval, meaning that there's no gaps. So a discrete relation is a relation where the independent variable is restricted to the values of the natural, whole, integer, or rational numbers within a given interval. So if you pay close attention to these definitions, you can also see that just because something isn't continuous doesn't mean that it's necessarily discrete. Okay, so these two here, there's more definitions than just a function or a relation being continuous or discrete. So these are just two possibilities out of a myriad of situations. So let's take a look here. I've got two examples. A price of oranges is 89 cents per pound versus a price for grapefruit is $1.75 each. So one of these is continuous, the other one is discrete. Now how can we tell which? Well, it has to do with what our inputs are. The input here is how many pounds of oranges you're buying, and the input here is how many grapefruit that you're buying. So if you've gone to the store, then you know that when you're buying oranges by the pound, they can be any value, right? It's just weight is a continuous measurement, or in this case, pounds is pressure and weight. So these are continuous values. So I could buy pi times the square root of 3 pounds of oranges. That's just some decimal, right? So there's no restriction. Pounds doesn't exclude any of the irrational numbers. However, if I'm buying grapefruit at the store, for instance, I can't buy a fractional amount. I can't buy 10/3 of a grapefruit. I can't buy 5/12 of a grapefruit. I'm also restricted from buying, let's say, pi grapefruits or the square root of 3 grapefruits. In fact, here I can only get positive whole numbers. Now, a thing to keep in mind is in these definitions, we've got within a given interval. So that means that we take a section of our x-axis, and along that section, are you allowed any real values? Okay? So the idea here is if I take the section of the positive real numbers, then that's perfectly fine. We can decide to do, I'm only going to look at my positive interval, I could only look at my negative interval, or I can look at both. But interval is an important word here. The same with discrete. So it's within a given interval. So let's take a look at exploring this idea in our next example. So let's take a look at the interval that our blue and red relations are using. So here, my red relation is using the entire x-axis here, both positive and negative. These arrows here mean this continues on infinitely. This arrow here continues on infinitely in both directions. Now, the blue relation is working on the interval from -4 to +5, but is restricted to only using integer values. That's the only spot where it matches up on the x-axis. So for instance, this is -4, -3, -2, -1, 0, 1, 2, 3, 4, and 5. So because of this, our blue relation here This is what we call a discrete graph. And our red relation, this is a continuous graph. Now, one way to do it with graphs is, it's actually quite handy, is that you can have a continuous relation if you can draw it without lifting up your pen. So if you can draw a graph without lifting up your pen, you can be sure that you're guaranteed to have continuous. Now here, we can't do that, so we should say, okay, so I can't draw it without being continuous. Look for your holes. If there are indeed holes, then we say, okay, this is discrete because I can see that holes exist. Now, in our next example here, things get a little bit tricky. We have to be careful with our definitions here. So I want to draw your attention to the blue relation first. So if I trace the hand over here, I can trace this out without ever having to take the hand away. So we can be certain that this blue relation is definitely continuous. So here I've got my red relation. So in this section here, perfectly continuous and fine. And then, okay, well, here I have to jump. So this is what's called a discontinuity. So this relation is still continuous in the sense that all my real inputs are allowed. So if I were to squash this line down to the x-axis and squash this up to the x-axis, all my values here, there wouldn't be any gaps. This dot here would fill in this open dot. So this is continuous in the sense that all real values are permitted, and we call it a discontinuity because of this jump here. So these are both continuous with respect to our x-axis. However, this has a discontinuity because of this gap here.